In this recording, we'll be showing you the technology page inside the Edge Deburring Recognition operation. Well, the first thing we have on the very top left is the actual chamfer parameters, such as what diameter of the tool you will be using for the actual chamfer itself. Let's go back for a moment to the tool, and you can see that we have a diameter that goes, as I described, from the bottom of 6 all the way to the top of 12. So what diameter do you actually want to use as the point that actually contacts the material? So I'm going to have that, the minimum in this case is 6, and that's because the minimum diameter at the bottom is 6. I'm going to have this at 8 millimeters. So it shouldn't work exactly at the bottom. I'm just going to have it there at 8 millimeters. We also have an option here called dynamic cutting diameter. Dynamic cutting diameter does the following. It will allow you to go around those edges between two different setting diameters. In other words, it can go sort of on a wave type of move on the part itself. This way, creating a condition where the edge on the tool is constantly changing. So this way you don't machine always on one edge, giving a little more tool life to your tool. I'm going to leave it right now at constant, and later we'll take a look at what dynamic cutting diameter does. Depth type, one way. Since I'll be doing this now in one step down, 0.2 millimeters, I can do that in one direction. And direction itself is going to be a climb cut. We also have an option here called change feed for feeding internal quarters. Sometimes you have an internal quarter and you may want to change the feed rate according to a specific diameter that it may head to. I'm just going to leave it exactly the way it is. I'm not going to make any changes over here. We have safety offset, and as you can see in the picture, that's a safety offset from the side of the tool towards this edge as it comes close along one edge to make sure it doesn't gouge the part over there. Now, I'm not going to do anything really over here because I'm already controlling that with my 3D model protection with a 0.1 millimeter offset. Cutting, as far as the step down on the part, do I want to have a specific step down or do it in one stop? I'm going to have it at one step down. One more issue I'd like to go into is the actual link. The link is how are we approaching the edges and how are we retracting from the edges. I'm going to leave it at arc, and I'm going to do save and calculate. Let's take a look now at the actual simulation, and I'm going to take a look at the solid verify situation so you can actually see the edge being defined. Click on play, and you see that it is going on all of these edges, creating a chamfer all along the part, including over here. Note the edge that had the chamfer on it was not done. And also note this edge over here. You can see that this edge over here, part of it was done up until here, but since it had to stay away from this corner over here, it went as far as it could go. Now, if I wanted to go a little bit closer to this corner, I can do that by going to my technology and using a larger cutting diameter. Say I'm going to use a larger cutting diameter of 10 millimeters. Save and calculate, simulate, again, using the solid verify. And again, we'll run our simulation. You'll note it does the bottom over there, does all of these edges. And let's zoom in actually to this area over here. You'll see that it got this time a little closer than it did in our last cut. In our next recording, we will show you how to work with dynamic cutting diameter.